Alright, we're going to quickly look at our line and we'll talk about conversion of units. So the line's probably very pertinent for us because these are some skill sets that we're going to need to apply as we go forward. So which one's easier? Let's start with the easiest one. Which one looks easier? The volume or surface area? Volume, which is a surprise because you probably didn't think that volume was the easier of the two probably a couple of months ago, but volume is by far the easier of these two. So what's the equation for a cylinder's volume?
IR squared times
Okay, length or height, doesn't matter. How does that work? What is a cylinder an example of? It is a, starts with P, the word we want.
prism.
Prism, very good. All prisms have something in common. What makes a prism a prism? No, what do you reckon makes a prism a prism?
Basically you can slice it.
You can slice it, and what should stay same as we slice it go? Cross-sectional area, correct? So this pi r squared, that's really our cross-sectional area times the length of our prism. Cool? So that's that slice, that area stays the same equation. So now we just sub in the variables that we know. So what variables do we know here? Do we know what volume is? We're trying to find volume, we don't know it yet, we will soon. So volume equals, do we know pi? Pi is just a number, correct? So we're just going to keep that as pi for now, because it makes it a bit easier. Do we know our radius?
Yes.
What is it? 3. It's half our diameter, which is 3, so times 3 squared, times by my length, which is 15. Are all my units the same here?
Yes.
I'm dealing with centimetres and centimetres, so I'm good to keep going. No. If my units weren't the same, what would I have to do first?
Convert them.
Very good. I'm glad you got the right answer. Maybe we can get our hands working at some point in time. But yes, convert them into the same unit. So we've got volume equals pi times 3 squared times 15. What do I do first? Do I do the 3 times 15 first, or the squared first, the pi times 3? Squared first, because of bombast, so we get pi times 15. Pi times 9 times 15, I'll just get my calculator out at this point in time. And that gives me an answer of? Point what? 1, 1. Am I done? Centimetres cubed, very good. So that is the volume of our cylinder. Happy with that? Now for our surface area, Sam, what's the best thing that we should do before we start any surface area of any three-dimensional shape? What should we do?
Write down the formula.
Formulas can be hard to remember off the top of our head though, can't they? So if we're a bit unsure about formulas off the top of our head, what should we do before that? Draw the net. So the net of the cylinder we know looks like this, correct? Does it matter where the circles are placed? As long as they're on opposite sides of our cylinder, correct? This side here, what does that represent on our diagram?
The height.
Yeah, the height or the length of perimeter 21. I'm just going to call it L to keep it the same. That's not the 6. This here, that is 6, isn't it?
Yeah.
Is there a way we can find out, I'm going to do it in red, is there a way we can find out this distance here?
6 plus 15.
6 plus 15. Now I've got any different ideas?
1 factor is
Yes, we know the diameter of the circle is 6. How's that going to help us?
circumference.
Circumference. Well, the circumference is used to find the diameter. So the equation for our diameter is, the circumference is pi times 2 times r, correct?
Yes.
Do we understand why that is that length there? If we don't, let's make an imaginary cylinder up here. Master English, at least it's useful for something, hey? If I've got this as my cylinder, correct? I'm about to make this into a cylinder that looks something like that, correct? What's the top side of that? A circle, and the outside of that is our circumference. When I unfold it, what does that length equal? It's the same as the circumference, correct? So that is how we know that top length. I'll put the line in the middle. Why put the line in the middle? It's the same for both sides, it doesn't really matter. Just to stop confusion, but I think I've added to it. 2 pi r is our length there, cool? So, let's go through the surface area equation. What have I got? What shapes do I have there? So my surface area, I have how many circles? 2 circles and 1 rectangle. So what's the area equation of a circle again? Pi r squared, and how many have I got? So I should have this equals 2 pi r squared plus my rectangle. What's the equation for a rectangle's area? Length times width. Do I know my length?
Yes.
Yep, so I can write length times, and what's my width again? Pi times 2 times r, correct? What do I know? Do I know all the variables in that?
Yes.
So I can just sub those in now, can't I? So surface area equals 2 times pi times 3 squared. You're 1 step in front, but that's good. Plus length, what's my length? 15 times pi times 2 times 3, which looks gross, but it's not too bad. What's 3 squared? 9 times 2. So I can get 18 pi. Plus, what's 2 times 3?
6.
What do we do actually? What do we do? 2 times 15 times 3. So we've got 18 pi plus 90 pi, which equals 108 pi, or we can just shove that into our calculator straight up. And what do we get for that? 339.29 centimetres squared. Silent thumbs, just little thumb raise if you got those. We don't need the whistling in the front row, thanks gentlemen. This is a percussion band. Silent thumbs if you got those correct. Okay, who got one of those correct? That's good, very good. Okay. If you didn't get those correct, is it the end of the world? Absolutely not. But going into our next bit of our lesson is probably going to help if we jot those things down, identify where we're making our mistakes. Sweet? What's the